Next concept, torque acting on a pulley. So here we have a box which is connected with a string, and that string is passing through a pulley, and the other end of the string is being pulled downwards by a person. So if you think of the different forces acting, so let's start with the object. Different forces acting on the object. So the first force will be the weight of the object acting downwards, and then since the box is connected with a string, there will be a tension force acting in the string, acting in the upward direction. And how do we figure out the direction of tension? It is always away from the object and along the string. Now coming to the pulley. Now, although it is the same string, but consider two sides of the strings which are connected to the pulley. So consider this is one side and this is another side. Remember the basic rule, the direction of tension is always away from the object and along the string. So in this case, pulley is the object. So the direction of tension will be both acting downwards as they have to go away from the pulley and along the string. Now, in all the previous chapters where we dealt with kinematics, forces, and work energy power, in all those chapters, we considered the tension on both sides of the pulley to be the same. But that is not always the case. The tension values on both sides of the pulley will be the same only if the pulley satisfies certain conditions. And what are those conditions? So let's read. Tension is the same on both sides of the pulley if number one, pulley needs to be massless. Number two, pulley should not have any friction. Number three, rope should be massless. So if all these three conditions are satisfied, only then we can say that the tension on both sides of the pulley will be the same. So if in the question they specify that the pulley is massless and frictionless and also the rope also is massless, then only we will say that tension on both sides of the pulley will be the same, T and T. But for this chapter, we are going to consider pulleys which are heavy, of course, which means they are going to have mass and they are going to rotate. And for rotation to happen, the pulley needs to have friction. So consider this diagram where it's the same object being pulled by a person, but the string is connected to a pulley, but the string is going around a pulley which is heavy as well as it will have friction. In this case, we need to figure out the tensions on both sides of the pulley. So the direction will stay the same as direction of tension is always away from the object along the string. So let's consider this side. Direction of tension will be acting downwards, and let's say that tension is T1. Now, since the pulley is not massless, it is having some weight. So on the other side, the tension will be T2 and the magnitudes of T1 and T2 will not be the same. And this small little detail we have to be careful of while solving questions. And how do we solve questions where the pulley is heavy? So the magnitudes of tensions on both sides of the strings are different, T1 and T2. Now, in these cases, when the string is being pulled by the person, the pulley is going to rotate. Now, since it is rotating, which means torques are acting. While solving the questions, we go back to the formula of torque, which is Rf sine theta, but R is critical here. We have two forces acting on the pulley T1 and T2. So here let us try to figure out the torques due to different forces T1 and T2. So the torque due to T1. In order to figure out the torque, it is important for us to finalize a point about which torque is to be found. So here we will find the torque about the center of the pulley. So torque due to T1, magnitude is T1, and what is R? R stands for the distance between the point about which torque is to be found and the point of application of force, which means for T1, we need this particular distance from the force and the center of the pulley. And this distance is the radius of the pulley. And that is why the expression for torque due to T1 will be T1 is the force, capital R, which is the radius of the pulley. That is the value of R which we need, and the value of angle is 90. So sine 90. R is the radius of the pulley. The value of sine 90 is 1, and we get the value of torque as T1 into R. And what will be the direction of this torque due to T1? Now, T1 has a tendency to rotate the wheel in an anti-clockwise fashion. So, the torque due to T1 will be anti-clockwise. Now, coming to torque due to T2, we'll use the same formula. The magnitude is T2. The value of small r will be capital R here, where R is the radius of the pulley. So, the torque will be T2 into R into sine 90, which simplifies to T2R, and the direction of torque due to T2 will be clockwise. Now, in the exam questions, we will be expected to figure out the net torque which is acting on the pulley. So, before we move ahead to figure out the net torque, do remember T1 and T2 are not the only two forces acting on the pulley. The pulley is having its own weight, so mg acting downwards. And also the pulley is connected with these two strings, which are also connected with the center of the pulley. But we will ignore all those forces because all those torques will be zero. Let me repeat, the weight of the pulley will be acting through the center of the pulley, and this particular tension and this particular tension, and both these strings are passing through the center of the pulley. And for this particular case, we are finding the torque about the center of the pulley. And remember the rule, if the force is passing through that point about which torque we are finding, then the torque will become zero. So torque of the weight of the pulley will be zero, and torques of the tensions along these two strings also will be zero. So the only non-zero torques which we have to consider is torques due to T1 and torques due to T2. Now one torque is anti-clockwise, another one is clockwise. So the net torque acting on the pulley we will write as T1R minus T2R. Now this will be the case if the anti-clockwise torque is greater than the clockwise torque. So T1 needs to be greater than T2. If we take the reverse situation, if T2 is greater than T1, then the net torque will be T2R minus T1R. Remember the condition, T2 needs to be greater than T1. And if we consider T1 and T2 to be the same, then the net torque will be equal to zero. And whenever the net torque acting on the pulley is equal to zero, this is nothing but rotational equilibrium. And in that case, we can say pulley is either not rotating or it is rotating with a constant angular speed.